The following is my first implementation to building a custom GPT to process raw audio files in the form of speech to text and to convert that into something more meaningful. This was one of my first iterations. First prompt. How would I approach the process of raw data processing in the context of building a template / structured formatting approach to convert dense, bundled text oration into a reflection of, quote, the same thing, end quote, with open bracket main topic, close bracket, and open bracket subtopic, close bracket, in brackets, question mark. Enter. Would this be a reasonable first step in a template format, or should I include a linguistic approach that includes text classification, part of speech tagging, or dependency parsing? Question mark. Enter. Complete first attempt at assimilating my instructions / intent. Then include 10 revisions that I could include to receive better results. So that was the first prompt, and then we had our response. Initial attempt to convert dense, bundled text oration into a structured format with main and subtopics in brackets. A preliminary template approach may involve pattern matching for key phrases. This includes identifying common structures that indicate main and subtopics and enclosing them in brackets. While this basic approach may work for some cases, it lacks sophistication and might miss nuanced variations. Revisions. 1. Incorporate named entity recognition, NER. Enhance the template by integrating NER to identify entities such as persons, organizations, and locations. This can help identify potential main and subtopics more accurately. 2. Utilize part of speech tagging. Introduce part of speech tagging to understand grammatical structures of sentences. This can aid in distinguishing between nouns, potential topics, and other parts of speech, providing a more refined approach. 3. Implement dependency parsing. Extend the approach with dependency parsing to capture relationships between words. This can help identify the hierarchical structure of sentences and improve the accuracy of identifying main and subtopics. 4. Explore sentiment analysis. Consider incorporating sentiment analysis to gauge the tone of the text. This can assist in differentiating between positive and negative aspects, providing context for the identified topics. 5. Optimize for contextual synonyms. Enhance the template to account for synonyms and variations in language. This could involve leveraging word embeddings or pre-trained language models to capture the contextual meaning of words. 6. Add context window analysis. Introduce a context window analysis to consider the surrounding words when identifying topics. This helps in capturing the broader context and reduces the chances of misinterpretation. 7. Customize for domain-specific terminology. Tailor the template to specific domains by incorporating domain-specific dictionaries or terminologies. This ensures better alignment with the language used in the given context. 8. Implement Machine learning models. Explore the use of machine learning models such as classification algorithms to learn patterns from a labeled dataset. This adaptive approach can adapt to diverse text structures. 9. Include regular expressions for specific patterns. Use regular expressions to capture specific patterns indicative of main and subtopics. This can serve as a complementary method to the more complex linguistic approaches. 10. Iterate and evaluate. Continuously iterate on the template, incorporating feedback and evaluating performance on diverse datasets. This iterative process ensures continuous improvement and adaptability to different text structures. Remember, the effectiveness of the approach depends on the nature of the data and the specific requirements of your task. Regularly testing and refining the template will contribute to its robustness and accuracy. For our follow-up prompt, we wrote, I like this approach. Can you draft a sample template as if I spoke 3,000 words and then I wanted it to be processed through this template? Can you create a formatting that includes incorporate named entity recognition, utilize part of speech tagging, implement dependency parsing, only use sentiment analysis when absolutely necessary, optimize for contextual synonyms? It's very important to add context window analysis. Add the ability to customize for domain-specific terminology. See if there's a way to include regular expressions for specific patterns. And the response was, certainly, below is a sample template that incorporates the specified elements for processing a 3,000 word text. And we got some Python code. Scrolling. There was a note at the end, and then I had a follow-up prompt. I said, how might I use this if I was copying and pasting text that was produced from voice-to-speech technology? Would I just paste in the text as a whole after this was included in my system processing requirements? Or would there be a template that would say, okay, copy and paste this text here, and then after this text has been submitted through the large language model, it might be cleaned and processed? ? The response was, if you are dealing with text produced from voice-to-speech technology, the typical workflow would involve copying and pasting the transcribed text into your system for processing. Here's a general guide on how you might structure the process. Number 1, workflow. User inputs transcribed text. User copy and paste the transcribed text into a designated input field or area in your system. 2, pre-processing. Before submitting the text to the large language model, you might perform some basic pre-processing. This could include removing any irrelevant information, formatting issues, or noise introduced during the transcription process. 3, submit to large language model. Once the text is cleaned and pre-processed, submit it through the processing pipeline that includes the template we discussed earlier. This pipeline performs various analyses such as named entity recognition (NER), part of speech tagging (POS tagging), dependency parsing, and other linguistic analyses. 4. Output display. The results generated by the template, NER, POS, dependency parsing, sentiment analysis, etc., can then be displayed to the user. This could be in a structured format, providing insights into the content of the transcribed text. 5. Further customization or analysis, optional. Depending on your specific requirements, you may provide users with options for further customization or analysis based on the processed results. For example, they might choose to explore specific topics, filter information based on sentiment, or customize the output based on domain-specific terminology. Template usage. For users, you would provide clear instructions on where to input the transcribed text. This could be a text box or a designated area in your system. Here's an example template usage guide. 1. Copy and paste the transcribed text. Users copy the transcribed text from their voice-to-speech tool, paste the text into the designated input area in your system. 2. Click Process or Analyze. After pasting the text, users click a button, e.g. Process or Analyze. The system then runs the processing pipeline, utilizing the template for analyzing and structuring the information. 3. View results. The system displays the processed results, including NER tags, POS tags, dependency parsing, and other relevant information. Users can review and potentially interact with the structured output. 4. Further interaction, optional. Depending on your system's capabilities, users might have options for further interaction or customization based on the processed results. This approach provides a clear and user-friendly workflow for processing transcribed text using the specified template. Users can easily understand where to input their text and how to initiate the processing. And then for the next prompt that we wrote, we said, hey, it would be helpful if you could explain these sections using natural language. So I'm to understand that we didn't understand what was going on in the code that was processed in Python. So we copied and pasted and asked it to explain it in natural language. The response: certainly. Let's break down the two sections in natural language. Step 7. Customization for domain-specific terminology. This step involves tailoring the analysis to recognize and understand terminology specific to a particular domain or industry. Imagine you're dealing with medical texts, legal documents, or any field with its unique vocabulary. To make the analysis more accurate in such cases, you can include domain-specific dictionaries or lists of terms that are relevant to the subject matter. This way, the system becomes more adept at identifying and categorizing terms that might not be common in general language. Step 8. Regular expressions for specific patterns. In this step, we use regular expressions to define specific patterns of words that we want to extract from the text. It's like creating a set of rules for identifying certain structures in sentences. The example provided is a simple grammar defined using regular expressions. Let's break it down. NP, noun phrase. It looks for a determiner, DT, followed by 0 or more adjectives, JJ, and ending with a noun, NN. PP, prepositional phrase. It looks for a preposition, IN, followed by an NP, noun phrase. Verb phrase, VP. It looks for a verb, VB, or any word starting with VB, like VBD for past tense, followed by either an NP or a PP, and this pattern can repeat. The regex parser then applies these rules to the POS tags of the text, creating a tree structure. The code then extracts specific patterns from this tree structure, focusing on noun phrases, NP, verb phrases, VP, and prepositional phrases, PP. Finally, the extracted patterns, along with their analyzed information, NER, POS, dependency parsing, sentiment, are combined to form a processed sentence, and this information is accumulated for the entire text, resulting in the processed text variable that gets returned by the function. And then I followed this up by asking, can you rewrite the template by including this text, then rewriting it using natural language? Okay, so yeah, can you rewrite this template by including this text? Yeah, include this text, then rewriting it using natural language. So at this point, I'm thinking that maybe we had another chat session open where we were copying and pasting it into this original core chat entry. The response was, certainly, looks like you have a structured format described in a diagram or pseudocode, and you want to incorporate the processing steps discussed earlier. Here's a natural language representation. And we have some produced code in Python, scrolling, 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 scrolling. It said this Python script outlines the natural language processing steps within the context of your provided diagram. Each step is explained using comments, making it clear how the template aligns with the specified processing requirements. We followed this up with a prompt, compare and contrast both versions. So it said, certainly, let's compare and contrast both versions. Okay, so we had the initial template without the pseudocode and the modified template that incorporates the given pseudocode. So this is the initial template, scrolling, scrolling, scrolling. And then this is the modified template. And now we have a comparison. Comparison 1, similarities. Both versions share the same fundamental natural language processing steps. They use spaCy for named entity recognition and NLTK for other linguistic analyses. Both versions include steps for sentiment analysis, contextual synonyms, and contextual window analysis. 2. Differences. The modified version includes a representation of a pseudocode or diagram you provided. Okay, so 2 differences. The modified version includes a representation of a pseudocode or diagram you provided, but the actual implementation doesn't directly interact with this diagram. Instead, the code follows the natural language descriptions provided earlier. The pseudocode involves a tool named formatter with various components like heading, structure tool, overview, etc. But these are not directly utilized in the NLP processing steps. The code includes the named steps but doesn't explicitly use the structured outline in the pseudocode. In essence, the modifications attempt to align the given pseudocode with the natural language processing steps, but it doesn't directly incorporate the diagram's components into the code logic. If there are specific functionalities or details from the pseudocode you'd like to integrate, additional instructions or details would be helpful. This video is a part of a larger series involving large language model culture commentary. Click here for a navigation aid on your screen now, appearing as a playlist. First video should be a hypergraph key. Second video should be a table of contents. Catch up on all things AI culture commentary with the following quick pick series. This is As an Aggregator, your first stop shop for curated content on YouTube.